Alright guys, go ahead and get started. So, I was saying earlier that I've already got y'all's first homework assignment slash lab, and I've got three papers here, or three sets of paper here. What you need. So I'm going to go ahead and pass these around. Please take my pictures. Have lab 1, which is, I believe, what is a robot. You should have lab 2, which is another one that's fill in the blank, and then lab 3. And the expectations for lab 3 is I want you to make sure you've got 2 robots picked. And you're not going to be sharing this in class, guys, so don't worry about that much of it. But I want at least a paragraph of what the robot's job is, what it's designed to do, and I want it in your own words. Do not copy and paste off the website. So let's say you decide, I'm just going to pull this up just because. So let's say you decide you want to do something from Boston Dynamics. Because, hey, robots are cool, right? Especially when they start getting a hold of them. So if you want to use that, you must cite I'm not so much worried about citation. You should cite it, but I don't want to hear, exactly word for word what these guys talk about when they talk about that particular robot. Does that make sense? Needs to be in your words, not their words. All right? All right. They tell you quite a bit about this little robot. As they go. All right? So like I said, I want that in your words, not somebody else's. The only person that'll be reading any of it is me anyway, so don't be shy. So I will go ahead and say this. If you don't want to write out your answers on this, I tried my best to do something that makes it a little more useful. So if you go to activities and all that, so this is how all this is set up. I'm trying to remember if it's in week 1. Oh, here it is. So basically what I've done is I took these forms. Come on. There it goes. I took these forms and I filled out and created this for y'all to submit. That way, if y'all want to, y'all can hold on to those pieces of paper. So those are out there under laboratory. Make sense? So I've got that for lab 1, lab 2, and then lab 3 turn-in. So you don't even have to print it out. You don't have to go find a library. You just go into your Blackboard site after you've typed up what you had to type up. And then you attach it to this guy, and it sends it to me for grading. Make sense? Alright, so that's your first homework assignment, guys. And I will give y'all till next Wednesday to get those done and turned in. Deal? You've got the whole weekend to work on it. You've got most of next week to work on it. There really is no excuse, and it's easy points, guys. It literally, as you read through it, you can find the answers to these questions. Doesn't take much. So that being said, please go ahead and get that knocked out for me, guys. It really should not take forever to do it. Should not really be that frustrating to do it. And make sure when you do these, guys, that you do it in pencil. That's the other thing I was going to make sure y'all knew. Do it in pencil. Why? Because I don't want to follow a pen roadmap. Okay? So go ahead and make that clear as crystal right now, is that I do not want to see, oh, that's not the right answer. I'm going to scratch that out with my pen and I'm going to start drawing arrows. Or I'm going to try and cramp my writing in right above it. I will take off points for that. So, pencil, please. All right. And you can go ahead, after all that, you can look through the labs that we've got up here. I will say when we get to the Lego labs, that's probably the most fun portion of this because we actually do a competition where y'all have to figure out how to do the programs yourself and make them do really, really well. Get your competitive spirit up and running. All right. All right. So any questions about your first assignment? I thought I had that fixed. I hate trying to do this one. Back over here. All right, that should have fixed it. Yep, that should have fixed it. So, in order to get to the more fun labs, we got to get the boring labs knocked out. You know, it's always how it goes, right? You don't get to go to the fun part until all the work is done. So that being said, I will try and give y'all a little time in class to do it, since I know some people have a hard time being able to do stuff like that at home. Or you might not have access to a library. Okay? Alright, so one of the things we talked about last time was robot safety. And Rich and I were. Alright, so we'll talk a little bit more about robot safety and what is required of it. Because robots are so big, some of them. Believe it or not, there's actually a ride at, I think it's Legoland, where you get to program a robot arm. You sit in a seat that's attached to the robot arm and it slings you around. Really, really cool. However, it also is one of those, really, that's an interesting way to deal with that. So, like I said, anyway, so it can cause damage to equipment because if you, again, these guys don't know where they're at or what they're doing. You tell it to go someplace, it's just going to get there as fast as possible with the easiest route possible, which sometimes means going through things, like a wall, like you. Proper safe guiding and training are essential because if you don't have the proper training, then a lot of things go wrong very, very quickly. It can go downhill in a half a second. So what do you mean by training? I mean that how many of you have ever gotten a job, let's say like at a warehouse, and you have to go through the safety training, you have to go through forklift training. You might have been trained as a forklift driver for 20 years. But the second you step into a new route to a new job and want to use a forklift, what do they make you do? You gotta go through training all over again, right? Why do we have that training? Some of it is that you're trying to make sure that people are up to date on it, but it also has to do with making sure you understand their policies and rules whenever dealing with that machine. Make sense? Hmm? I mean, that's pretty much how all of it runs, is that I don't care what job I've ever been to, there's always an orientation and where they go over, don't leave the ladders on the floor, OSHA hates that. Don't leave this here, OSHA hates that, or, all that kind of stuff. They want to make sure you're familiar with their rules, especially when dealing with, because the way a lot of people tend to do things are very similar. They can also be very different. The walkways for pedestrians generally will cross over for forklifts, right? So it becomes a question of what are their policies and procedures dealing with interactions between humans and the forklift, or just the forklift and the product. Some people say, well, a forklift, you shouldn't put it more than halfway under the pallet before you lift it. Others say you should go all the way through. All of it's always dependent upon who you're talking to, right? Because I've used pallet jacks for years. I've always thought you're supposed to go all the way through. I had somebody tell me one time, no, you're supposed to only go halfway. At the same time, if you got heavy product on that sucker, that's just going to end up tipping everything over. It always depends on who you talk to, what the rules are. But the biggest and most basic rules are determined by, this particular one is ANSI, the American National Standards Institute. and the Robot Industries Association. And these are providing requirements for industrial robot manufacturers, remanufacture and rebuilds, installation, integration, safeguarding, and making sure that everybody follows the right thing they need to do. In other words, they're the ones that make sure that you understand you have to put this sucker away so that it can't get anybody. Does that make sense? I will go ahead and tell you now, the only reason safety rules ever changed, does anybody know why? The most general rule of thumb, safety rules don't change until somebody is either hurt or killed. And then all of a sudden they go, oh, we need a safety rule for that. The person was climbing on the outside of the play equipment. Why should that need a safety rule? So y'all remember all that kind of stuff as a kid, right? They say, don't climb on the outside of this. Don't climb up this. And you sit there and go, okay, why? Well, because somebody hurt themselves, and now that's an issue. Right? How many of y'all remember when the coffee cups did not have to say, caution, the beverage you're about to enjoy may be hot? Rules only change when somebody gets hurt. Okay? So that being said, the way they try and protect people is by creating these rules and say, hey, don't go in this area with the robot. You would think you would not have to say that, but enough people have been struck and hurt by the robots. It has to be said. Does that make sense? So then you've also got OSHA. OSHA's never anybody's favorite thing to talk about, right? They have their own setup where they have to say, okay, this is about health and safety. What is the... They're the ones that everybody always loves and has a love-hate relationship, because they're the ones that make sure your workplace is a happy, healthy place to be. On the other hand, they're also the ones that come behind you and scold you if you don't do it right. Right? So before they ever install a robot, they have to do what's called a risk assessment. Okay? This is where they have to look at what is the robot going to have to do as the task. Where is it going to be? Because location is everything. Are you going to stick this sucker in a corner, or is it going to be out in the middle of the floor where it's got to be? You need to know what kind of programming procedures you have to deal with, the normal mode of operation, malfunctions and corrective actions, and stored energy hazards. What does it mean by stored energy hazards? Yes and no. Okay, so stored energy. How many of y'all have ever worked with hydraulics or pneumatics? A few of y'all. They tend to store energy, right? Even when you turn them off, they still have that pressure unless you drain the what? Unless you drain the lines, right? So if you're the person that has to go up to the robot, one of the things you want to do is A, turn off the air, but B, you want to do what? You want to drain the line. Why? Because that gets rid of any potential for you start messing with that gripper, or you start messing with anything that's got it has pneumatics or hydraulics or electrical, or even something mechanical like a spring. You want to get rid of those stored energy hazards, because otherwise it might come back and bite you, right? So what kind of energy hazards are you going to have when you're dealing with this? Where is it going to be? What is it going to do? What kind of normal operation is it going to have to do on a daily basis? This is a lot of stuff that when they decide to get a robot, this is what you have to do, the steps you have to take. Most accidents are caused by programming, testing, inspection, and repair. Most accidents occur because most people are not paying attention. They're busy thinking about the weekend, either the one that they just finished or the one that is coming up. Right? Where should your brain be? Where should your mind be holding to? Doing exactly what you need to do to keep yourself and those around you safe. That is where your head needs to be at all times. Because the second that you don't hold that in mind is going to be when you end up hurt. I'll tell you that now. So programming. This happens because you get into the case with the robot because you've got to mess with some of the parts of the programming and get touched up on different places it's got to be. You're not paying attention and the robot is still running full speed. Like I said, most of the time if you're doing it if you're trying to mess with that program, slow it down. It might take it longer to get from point A to point B, but it means that if you get caught in a pinch point or you get caught under the robot by accident, you don't end up hurting yourself or others. All right? Testing, running the rig and saying, okay, is it running okay? Oh no, that part came loose. Instead of stopping the robot, you go in to try and fix the part, right? And the same goes for inspection and repair. So getting caught, getting struck, getting pinned, and getting flung. Okay? How many of you know what a pinch point is? That's where two pieces of something come together and it will grab hold of you. Getting struck, exactly what it sounds like. Being pinned, again, not pleasant. Or actually going for a flying lesson. None of it's fun. None of it's anything any of us want to do. That's why I always try and make sure everybody understands. The robot is not something to be feared, but it is something to be respected. Does that make sense? All right. We're going to go ahead and take a short break, guys. I see most of y'all are. One of the most common things we use as far as keeping people away from the robot is we used a fixed barrier or a fence. Why a fence? Well, makes it that much harder for people to get up to it, right? We make sure that you cannot really go over it. We make sure you can't get under it. You don't want to be able to get around it. So basically we try and make a barrier that is not easily passed because we are trying to keep everybody out of the robot's workspace, right? It should not be easily bypassed by any means. And one of the things we use just to make sure that we can get in should we need to is we use a interlock barrier. This uses gates equipped with interlocks. When the gate is open, all equipment stops. We have interlocks very easily seen on these three robots here. The interlocks on the guy at the far end, the KUKA, are actually internal interlocks. They're built into the equipment itself. Make sense? But for these three, you can see those little red boxes in there, the red and black boxes that are right where the doors are. Those are the interlocks. In order, huh? Yes. They have pins that go in them so that they can tell if the door is shut or if the door is open. If the door is open, it will not run programs. Make sense? All right. So this is a very typical work cell with your fenced-in barriers. If you notice, they go all the way to the bottom, and they're fairly tall, mainly because if somebody is going to get in over the top of the barrier, I'm pretty sure somebody will see them before they actually get in there. Right? That's kind of what you want. Some of the other guarding methods we use very liberally a lot of these. Pressure mats, not mates. We use pressure mats. So if you don't know what a pressure mat is, if you walk up to automatic doors, some of them use pressure mats instead of motion sensors to let everybody know that you're there, so they can let you in. Light curtains are very common. Anybody know what a light curtain is, or does everybody know what a light curtain is? For those of you that do not know, a light curtain is basically, think Mission Impossible with all the light beams going everywhere. Only you have one side that's pushing the light beams and the other side's receiving them. If you go through those and you break one of those beams, all production stops, or it will not start up until you leave that area. Does that make sense? So we're looking to detect the entrance of a person into a hazardous area. Emergency braking, it breaks the motion of the robot instead of completely removing power. You have awareness devices that can define a safe perimeter. And you can use warning systems, but they cannot be used alone. Why? Because you want to make sure somebody somewhere is aware that there's somebody trying to mess with the robot, right? Oh, you didn't do it right. You're not supposed to be in the area with the robot whenever you start the robot, kind of thing. So presence sensing, again, there's a light curtain right there. As you can see, it's got those beams back and forth. Now, these beams do not actually have color. This is not Mission Impossible, which I don't know where they got how Hollywood got the idea that you can spray or throw dust or something at laser beams and they actually show up. I personally find that's hysterical. Why? Because laser beams are invisible. You cannot force light to show itself, right? Not unless you're dealing with the dark. So this is a way for them to sit there and say, hey, you know, there's somebody in the area that doesn't need to be there. Unauthorized personnel are not permitted. Pressure mat is what this one's showing you. And these are different, the ones in red are the different trying to get ahead of myself here. These right here that have the red tops to them are door interlocks. You have an emergency stop button. Now, I will go ahead and tell you this. Most of the time, these robots are carrying heavy payloads. Now, what does that mean to me? That means that if you start slamming that emergency brake, what's going to happen if you have a heavy payload on this robot? Think 18-wheeler slamming the brakes. Eventually, it does a lot of wear and tear on the robot, just like it does on your car, right? How many of you slam your brakes whenever you're driving your car? Or do you just do a gentle stop push? There's a reason for that, right? Because if you slam your brakes every time, what's going to happen to your brakes and rotors or your brake drum? It's going to wear out, it's going to grind it, it's going to cause a bunch of problems, yeah? So with the robot, if we can help it, there are buttons on these that basically are like a hold button. It's what brings the robot lets it finish its motion and puts a gentle brake to it instead of coming to a sudden halt. The reason you want to use that instead of the e-stop, if you can, is because if that thing has a heavy payload, you might cause damage to the robot as it slings itself back and forth with that payload. Does that make sense? And then you have some limit switches over here. Everybody knows what a limit switch is? Any questions on limit switches? Because we'll go back and talk more about these later. They're just a very common way of sensing that something is there. Okay. So here's another barrier showing the robot in an installation. So generally, depending upon the robot setup and how closely they are working with humans, depends upon the amount of safeguards you need between you and that robot, as well as exactly how fast he can move through a program. Those standards are set by ANSI and OSHA. So the most common form of safety barrier is the fencing. However, if you have to work closer with the robot, you might end up using pressure mats and light screens. Any and all robotic, well, just like anything, it's always situational. And if the situation calls for the robot to be on the floor where humans and it are interacting closely, then you're probably going to end up having more safeguards than if you say have it put away. So control devices. These must be located outside of the work envelope. Now, what do we mean by work envelope? The other word for it is workspace. Okay, the other word for a work envelope is workspace. That's the more common term for it. I need to probably go in and change that. So what do we mean by workspace? Well, a robot, does it have the ability to get up and move? Does it? Can it just jump up and go to the side to wander around? No. It's bolted to the floor, right? So its workspace is anything it can reach within its area. Does that make sense? So control devices like, I don't know, the controller for the robot, we do not put that in the cage with the robot. Why? Because if the robot goes haywire, spins around, and hits that, it basically destroyed its own brain. It's kind of expensive to replace. It must be in sight of the robot. So it must be able to be in sight of the robot. So if I'm running that robot, I need to be able to know that I go to that control device, I can still see what the robot's doing and make it stop or make it slow down, right? I need to be able to visually see that robot. Must be clearly marked so the purpose is obvious. It should be guarded to prevent accidental operation. Okay? E-stops or emergency stops. Any of you work around these kind of things, you know that e-stops are everywhere, right? Why are e-stops everywhere? Because at any point in time, you need to be able to stop everything, shut it down, and say, okay, let's figure out what's actually going on here instead of letting things continue on into a dangerous point. Right? That's why on any manufacturing line, you have e-stops everywhere. Why? Because if it needs to be shut down, it needs to be shut down. You don't want to wait 20 minutes for it to shut down if you've got to run halfway across everything to go turn off the circuit breaker or something, right? Personnel training is something everybody goes through, and they're supposed to walk you through where any and all, if a problem occurs, you need to come over here and do this kind of thing. That's all what that is. All right. For installation, there are certain safety codes with these robots. The thing is, a lot of robots are fairly good sized. And if you don't follow the safety codes, you risk them tipping over and ending up on the floor. I wish I actually had the Fanic up and running. Right now, he's got a bad joint right now that we're getting fixed. But the thing about that Fanic is you can actually see whenever he's in full motion, he actually moves his cage. I've seen him moving his cage so hard he actually bumps it off from the wall and moves it forward into the room. These things are powerful, and when they start slinging their weight around, it's quite something to witness. All right, so follow the manufacturer's preventative maintenance schedule. That's always something it's a good idea to do, right? That preventative maintenance schedule, what is it supposed to do? Exactly what it sounds like, right? It's supposed to prevent the robot or whatever mechanical equipment you have from breaking down. To do all that, you need to make sure you're doing what? Before you ever go near something that's powered, what should you do? Huh? Cut the power. Not just cut the power, but what? Lockout, tagout, right? I don't care what stored energy you're using, hydraulics, pneumatics, or electrical, mechanical. If it has some way that needs to be de-energized, you lock out, tag out. And why is that? Why is that such a big safety thing to lock out, tag out? Because it would really, really be terrible if somebody came and turned that on while you got your hands in it, right? It's kind of like somebody's working on equipment around your house and you don't know that they're working on it at that time. Let's say they're working on the sink. You don't notice that they're working on the sink. You just come in and start running water. All of a sudden, you got water everywhere in your house. That's why you lock out, tag out. All right. So programming, when in teach mode, only a qualified programmer should be controlling the robot. And everything should be at a slow speed. Again, that's just so that when that robot starts moving, you're able to get out of its way. The biggest preventative of most accidents is training, believe it or not. That's why companies spend lots of money every year training their employees to make sure that they don't put themselves in hazardous positions. Does that make sense? Why? Because it's easier to train them not to get into those positions in the first place than to pay for wrongful injury or workman's comp. You know? So effective safety programs must be included in the training. All employees should be made aware of the hazards that exist and the safeguarding measures in place. Okay? And what are the safe practices necessary for you to perform your job? Most jobs do this, right? Or they're supposed to. So every company should have a safety policy written somewhere, and that includes for robotics. Okay? Because do they have time to sit there and go through every safety policy, procedure, and rule? No. But what do they generally do? They give you a manual and say, here, happy reading. Technically, they have given you the material, and it's up to you to read it and understand it. Because as long as they give you that material, they are legally safe. They are generally legally safe because they can sit there and say, well, I have provided them with these. What happens after that is not my fault. So only workers who have received adequate training in hazard recognition and control of the robots should be allowed to program, operate, or work around it. Okay. So again, we're looking at the word envelope, but change envelope to workspace. And it means the same thing. So basically, if you bolt this chair to the floor, what is your workspace? What would be your workspace if your chair was bolted to the floor? Anything you can reach, right? Long as you do not move from where you're sitting, it's everywhere you can reach within that area, correct? Same thing goes for a robot. So one of the things you have to do is be very careful when you're getting in his space. Why? Because he does not like people in his space to begin with, so you got to make sure that you don't get too close to a bad situation. So I will tell you this. We actually, with this robot here, the ABB, we had a camera that somebody ended up destroying. So if you see the little black box that's around the camera up there now, there's a reason for that. So somebody can't just knock that off. Most robots are very expensive. Talking thousands of dollars in investment. And that's not always including that vision system, which, well, how much do vision systems cost? What do y'all think? Round ballpark figure. A couple hundred? Maybe even a lot, somewhere close to 1,000, depending upon the sophistication of it. Everything that's got to go with it, right? So when it comes to the robot, you have to make sure that when you are working with it, you have the understanding that you're dealing with a very expensive piece of equipment. And not just very expensive, but it's a precision-driven piece of equipment. Now, what do I mean by precision-driven? Exactly what it sounds like. These guys have the ability to go back to the same point over and over again, day in, day out, and never miss it. If they miss it, it's within micrometers. Almost the width of a human hair. They've got them that precise. We can't do that, right? I mean, heck, if you just took a pen and a piece of paper and you just move your arm up and down, what would happen? Huh? Well, if I just take my arm and move it straight up and down, for an example here, I was just sit here and just that many times, what do I have? Do I have one dot or do I have a small grouping of dots? I have a small grouping of dots, right? And the same thing will happen no matter how long I sat there and did the same thing. My grouping would just become the same and would start to overlap. We cannot do true extreme precision like the robots can do. But that being said, if you collide the robots, if you tear up the end of arm tool, that's an investment that you're going to have to wonder how to fix. And it's not cheap. Like I said, respect the robot. All right. I think we've gotten through most of this. Yep. So that's the whole first chapter of the of robotics, guys. So, what time does this class get out? Get that 11, right? All right. And let's move on to chapter 2. Yes. Wednesday. Is it imperative that you leave? Then